Hi guys, this is Mr. Urrego, and today we're going to learn compound inequalities. As you can see, we have two types of compound inequalities, and or. Okay, so why do we call compound inequalities? Because you're going to have, as you can see in the example, you have two inequality symbols, or you have two inequalities in one, right? So that's the idea. You have two inequalities in one inequality. We're going to graph this in only one number line. So let's start with the first one, which is and. That means I put an and in between the two inequalities, and then the idea is the same. I need to solve, graph, interval notation, and set builder notation. Set builder notation. Okay, so I'm going to solve, graph, interval notation, set builder notation. Let's finish that word, set builder notation. All right, cool. So let's solve this one. The idea, when I ask solve, that means the x has to be by itself. Right now, the x's are by itself. So done. I just need to graph. Let's graph. So what happened is the following. Because I have two inequalities and I need to graph on one number line, this is what I'm going to do. First of all, we need to locate the values, 4 and the 10. So let's pretend the 4 is here, and let's pretend the 10 is right there. So what I'm going to do is I'm going to graph x greater than 4 on the top, x less than or equal to 10 on the bottom, and then our final answer will go on the number line. Okay, so let's go with that. Let's change the color here, and let's go with green. Let's see how green goes. X less than 4. All right, as we understand, open circle because it has no equal. Greater than 4, greater goes to the right. All right, now let's do the same with the other inequality, and let's use blue for that one. X is less than or equal to 10. I go to 10, solid circle because it has an equal underneath. X is less than or equal to 10. And that's my graph. So I have the graph of both of them. But again, when I'm doing a compound inequality, I need to graph it in the number line, both together in the number line. By the way, if you're not sure how to graph inequalities or any of this process, please check the link of the video in the description with the basic linear inequalities. So I showed the whole process there, solving, graphing, and interval notation and set builder notation. Let's continue. So when I'm doing and, as you can see, I wrote here is in the intersection. So when doing and is the intersection between the two lines. All right, what's in common for both? Before, I don't know, elementary school or I don't know when, let's say that this is set A and set B, right? The intersection between the two of them will be right here in the middle. That's the intersection, something that is in common for both. What's in common for these two graphs? So my green graph starts at 4 to the right. My blue graph starts at 10 to the left. So basically, my graph is between 4 and 10. Here is where I have two graphs. This is the area that is in common. Okay? What happens here on the left is an open circle, so I have to have an open circle. On the 10 is a closed circle, so I need to have a closed circle. And my graph is in between the two of them. So this is an AND graph, always between the two values. All right, greater than 4 to the right, less than negative 10. All right, let me give you another example. Okay, so this is one way how to write the n inequalities. Another way how to write the n inequalities is by putting the x in the middle. Okay, so let's write this one down. Let's say that I have negative 3 less than or equal to x is less than 5. This is an or and inequality. Why? Because the x is in between the two symbols. Notice that the graph is in between the two values. The x is in between the two symbols. Now, the idea is always to solve, but right now the x is by itself. So right now I just need to go straight to my graph. So let's go straight to my graph. Okay, so what's my graph looks like? So if I have two values, what I bring down those two values, -3 and 5. X is in between the two values. Let's read here. Let's read from the only one inequality symbol. X is less than or equal to -3. So I go to -3, I do my closed circle, and I read X. I read always from the X. X is greater than or equal to -3. Greater goes to the right, okay? But it has another limitation. The other limitation is the other inequality symbol. Let's do the second one. Let's do this one. X is less than 5. So I go to 5, open circle, less than. It goes to the left. You see that? So my first inequality, X is greater than -3. Greater than -3 goes to the right. But my second inequality, X is less than 5. 5 goes to the left. So what are the values that are between -3 and 5? Is this in between those two. So this is an AND inequality. This is an AND graph. For the most part, 95% of the times you're going to have a graph in between. There are special cases though, right? So let's work on something more complex, but this is the basic idea. Okay, so we have this inequality. As we can notice, we have two inequality symbols in this case. So because we have two inequality symbols here, then those two inequality symbols are going to divide the whole inequality in three pieces. The middle, which is between those two symbols, the right side, and the left side. And I'm saying this is because the whole idea is to solve for x, right? Leave the x by itself. So in order for me to solve for x, whatever I do in the middle, I'll do on the right, I'll do on the left. Let's start. Cancel the 4 is negative, add 4, in the middle, in the right, in the left. -6 plus 4 gives me -2. Bring down the 2x, keep the same inequality. The 4's will cancel, -4 plus 4 is 0. And then I have 2 plus 4, which is 6. Keep the inequality symbols the same direction. Next, divided by 2, right? Middle, the right, the left. 2 divided by 2 is 1. It cancels out, so I'll bring down the x. Symbol, don't forget the equal, okay? And then -2 divided by 2 is -1. 6 divided by 2, 3. The x is by itself. I am done. Let's graph. Number line. Remember, everything has to be in the same number line. All right? So -1 is less than 3. I always want to have the smaller number on the left side and the bigger number on the right side. So my inequalities make sense. -1, let me bring -1 down, and let me bring 3 down. Okay? X is greater than or equal to -1. Greater. So I go here. Because it has an equal sign, then I'm going to fill it out. Solid. X is greater. Means I go to the right. But also x has to be less than 3. So I cannot go beyond 3. I go to 3. No equal sign. Open circle. Because it has no equal. X is less than 3. And I complete my graph. So my graph is between -1 and 3. Alright? X is greater than -1, but x is also less than 3. So this is my graph. For the most part, this is going to be my graph for an AND inequality. Remember, AND inequality is either you have an AND or the x is in between two inequality symbols. Now let's write the inequality, let's write the answer in interval notation. My smallest number is -1. My biggest value is 3. -1 is included, therefore I put a bracket. The 3 is not included, therefore I put a parenthesis. And this is my interval notation. What about set builder notation? So set builder, I always start with brace, x, and bar. So this is read as the set of all x such that, and at this point I bring my inequality symbol. Let's read. I bring this inequality symbol into my set builder notation. So -1, the same thing that you have in the inequality, and that's my set builder notation. The set of all x such that x is greater than or equal to -1, but it's also less than 3, and you close with the brace. Okay? Let's do a more complex problem. All right, let's say that I have, something like this. -3 is less than or equal to 3 minus 2x is less than, let's not put an equal on that side, so we get used to work with anything. Okay, and again, the idea is to solve, graph, write an interval notation, and set builder notation. Same as the previous one, I have inequality, inequality. In between the two inequalities is my middle section, the left section to the left, the right section to the right. Whatever I do in the middle, I do in the right, I do in the left. Middle. To leave the x, I gotta cancel the 3 first. It's positive, subtract, subtract, subtract. Middle. 3 minus 3 is 0. Bring down the -2x. Keep the inequality symbols, whatever they have. On the left side, -3 minus 3, -6. On the right side, 9 minus 3, 6. Let's keep going. Leave the x by itself. I gotta divide by -2 in the middle, on the right side, and the left side. Now here comes what's different about inequalities. Every time I divide or multiply by a negative, my inequality symbols will flip, will switch the direction. Every time I divide or multiply by a negative number, I flip the symbol. So this is less than, it becomes greater. This is less than, it becomes greater. You have to flip both inequality symbols. Okay, be aware of that. Next, -2 divided by -2 gives me 1x. I don't need to put the 1, bring down the x. -6 divided by -2 gives me +3. 6 divided by -2 gives me -3. And the x is by itself. Technically, I am done. In order for me to graph this in the number line, I always like to have my smaller number on the left, my bigger number on the right. 3 is not smaller than -3. So this has to be flipped. -3 comes here, and the 3 goes to the other side. My symbols have to be flipped as well. So this comes here, this goes there. Let's double check. X is greater than -3. X is greater than -3. That's right. This is the second one. X is less than, right? The angle. X is less than 3. X is less than. So yeah, this is right. Okay, it looks better. Small number on the left, bigger number on the right. It's going to avoid a lot of mistakes. Let's graph. My small value on the left side, my bigger value on the right side. X is greater than -3. Open circle because it has no equal. And x is greater, means greater goes to the right. But my x is also less than or equal to 3. It has an equal, solid, less to the left. So in this case, it's in between -3 and 3. And this is my graph. Any value that is in between -3 and 3 will satisfy my inequality. Interval notation. I bring my two values down. My -3 is the smallest value. My 3 is the bigger value. In between a comma, right? -3, comma 3. Now, open circle, parentheses. Close circle, bracket. Bracket because it has an equal. So this is my interval notation. Set builder. Brace, X, and bar. You always start with that. And then you bring your inequality. -3, X, 3, close. So I solve my graph, interval notation, and the last is my set builder notation, which you read the set of all x such that x is greater than -3, but is less than or equal to 3. And we're done. Right, let's work on the OR inequality now. So now I have an inequality with an OR in the middle. Okay, so I solve it. Okay, is the x by itself on, well, in this case I'm going to have two inequalities, you see that, separated by the word OR, right? If you remember, when we had AND, we said it was going to be the intersection between the two of them. When we have OR, it's going to be the union. So let's check that out. So let's graph. Okay, I have two values. Which one is the smallest one? The 0 and -2. That's right, -2 goes on the left, 0 goes on the right. So let's graph each one of them on the same number line. X is greater than or equal to 0. 0, close circle, X is greater, to the right. Big arrow so we can see that. Or X is less than or equal to -2. Go to -2, it has the equal, solid, X is less than, to the left. So 90% of my OR graphs will be pointing at the opposite directions in my number line. 95% of my graphs will be like this. Okay, now what about my interval notation? Okay, so what's going to happen is the following, and let me make sure that we understand that. When I'm doing OR, is the union. Okay, when I'm doing OR is the union. So when you did this in different classes, I don't know if this would happen in elementary school or middle school or high school, to tell the truth. So when this happened, when you did these sets, all right, let's pretend that this is A and this is B, union, so this is A, the whole circle on the left, and the whole circle on the right is this, right? You notice that we have something that is intersecting here, and this is the piece that we'll use for AND. But for union, I take both, everything, okay? So an OR is a union of both inequalities. Therefore, when I draw my interval notation, I got to write this one, union, with this one, united with the second one. So it's going to be both, not only one, both. So let's write that down. So let's write the inequality symbol for this. To the left, it starts from -infinity all the way to -2. Infinity, parenthesis, -2 is included, bracket. This inequality starts at 0, it goes to the right, it goes to positive infinity. Infinity, parenthesis, my 0 is included, bracket. So this interval notation is for this inequality, this interval is for this inequality. Because we're doing OR, it's a union between the two of them. And this will be my interval notation for this graph. Okay? Now, if I'm going to do set builder notation, same thing. X, the set of all x such that you bring your inequality when the x's are by itself. You bring all of that. X greater than 0 or x less than or equal to -2, and you close. For your set builder notation, you always bring the whole inequality after the bar. Set of all x such that after this you bring your inequality. So it is confusing, it is not too common, but it's simple to write. All right, and that will be my interval notation. Let's try another one. So now we have this problem, okay? It's with an OR. Let's solve it. All right, remember the word OR and two different inequalities. We gotta solve individually. Divided by 3. I have the 3's cancel. X is less than -2. And that's by itself. Or, let's solve this one. +4 plus 4. -4 plus 1 is 0. Bring down the -2x less than -10. Divided by -2. Remember, I am dividing by a negative number, therefore my inequality symbol has to flip. The -2 divided by -2 cancels, get equal to 1, so x is greater than 5. Alright, so let me bring this down. X is less than -2, or x is greater than or equal to 5. So this is my final answer. Let's graph. Remember, we graph on the same inequality. Which number is smaller, -2 or 5? -2, so that goes on the left side, and the 5 goes on the right side. Let's graph individually on the same number line. X is less than -2, so I go -2, open circle, less, to the left. Alright, my arrow. Next, x is greater than or equal to 5. I go to 5, and it's going to be solid because it's equal to. X is greater, and greater goes to the right, and I have my arrow. Okay, so as an OR graph, I say, for the most part. In interval notation, remember, an OR is union, right? So interval notation, the interval notation for this, it goes from -infinity, parenthesis, all the way to -2, parenthesis, because it's not included here. From 5 to the right is positive infinity, right? Oh my god, it's a horrible infinity. I'm sorry about that. Horrible infinity. Here we go. Let's get back again. Pen color, and let's work this out. Here we go. Positive infinity, something better. 5 is included, bracket. Infinity, not included, parenthesis. And because we're doing OR is union, so I put a U in between. This union to that, united to this. Interval notation. Set builder notation. Brace x such that. The set of all x such that, and I'll bring my inequality symbol. My final inequality. So x less than -2, or x is greater than 5. Again, when we learn more set notation or logic notation, that's a better word, we can write this in a different way. Algebra 1, algebra 2, intermediate, many classes, this is fine, okay? If you know more logic symbols, then you can write this in a different way, all right? But again, this is nice, this is good, okay? So again, solve, graph, interval notation, set notation. Now, all this is beautiful because all of them are working. Let's do one that will not work. So let's do something like this. This is an and question, it doesn't matter, and or. I just want to make a point. So let's solve this. Divided by 2, divided by 2. 2's cancel, x greater than 0 divided by 2 is 0. Okay. Solve the inequality. +1, +1. In this case, I had two inequalities separated by the word and. Remember, I can have that or I can have the x in the middle. So I solved that one, x by itself, solve this one, -1 and 1 is going to cancel out. Bring down the 4x, less than or equal to, -9 plus 1 is, divided by 4 on both sides. X is less than -4 divided by, -8 divided by 4 is -2. Let me bring this one a little bit lower, 0 and this. So I'm done. Okay, this is my inequality. I just solved it. Here we go. We graph. Okay, so I gotta graph both on the same number line, but I need to make a point here. So let's do one at a time, and let's do -2 here. Let's do 0 here. Remember, every time I'm doing and, is an intersection of the two graphs. Okay, if I do OR, is a union of the two graphs. Keep that in mind. We do an AND. So let's graph one at a time and let's check those graphs. So let's do one with green. Start here. X is greater than 0. So I'm going to go to 0. I'm going to put it on the top. Greater to the right. Alright, let's change the color. And let's do magenta, for example. And let's do the second inequality. X is less than or equal to -2. So -2. Less than or equal to -2. I go to -2 and it's going to be a solid dot. Less than or equal to the left. Okay, interesting. I have the two inequalities, but I know that they have to be the intersection because I'm doing AND. AND. Is there any intersection? Is there anything in common between these two graphs? Is there anything touching at all? No, if there was something touching, it should be in the middle, right? There's nothing touching. So therefore, what is my answer? There's nothing. There's no intersection. There's no graph intersecting. Technically, if I have to graph that, that's my graph. There's no graph. There's no intersection. So because this happens, then this inequality has no solution. Okay. Another way of saying it is the, oh, this is a brace, horrible brace. What I'm trying to say is I'm putting the solution inside this bracket, these braces. I'm putting anything there because there's no solution. It's the empty set. Empty set. That's a Greek word. Phi, I believe. That's how you read it. So let me do those braces again better. Empty set. Empty set. Empty set. Empty set. Nothing. There's no solution available for this inequality. Even though we solved it, we graphed it, but when we look at it, it didn't make sense because my answer is the intersection. So like I said, this will be my solution for this inequality. Okay, I need to make a point saying after I solve and I graph, I have to say there's no solution of the system because there's no intersection between the two graphs. That would be the full explanation. There's no solution for the system because there's no intersection between the two graphs. All right. Other way is empty set, or using this letter, Greek letter, which means empty. So like I said, 95% of the times they'll behave the same way that we did before. Okay. In between the two numbers, this will be AND, opposite directions, or for the most part, but sometimes we ended up with this type of problems. All right, guys, I hope this is clear. The idea with this problem was not to confuse you, but to make sure that you understand that sometimes it doesn't work the way it's supposed to do. All right, make sure you subscribe to the channel, please, like the video, hit the notifications bell, and I'll see you in the next one. Thank you very much for watching. Take care.